Right. So, do you want to, sorry for the interruption, I changed, stopped and, restarted the recording. I would delete these small clips and would leave the next clip over there. Yeah.
Cool. Thank you.
Now, we assume that in the LO1, we did understand the concepts of networking. Yeah. The network, the networking, the protocols, the devices, and additional feature like a wireless network. Yeah.
Yep.
Now we are familiar with the equipment and the concepts. Now we want to create a network. Yeah. Not only the create word is maybe not suitable, but we have to build a network. Yeah. A build requires the plan and the design and then implementation. Yeah. So when you try to build a network, it means you want to plan it, you want to design it, yeah, and you want to implement it. So three things involved there. Yeah. So let us move little bit according to a design brief. Design brief means a client brief. So how you would be going, basically you need to have some objectives. Which objectives? You should have some goal, that what do you want to do, choices, what choices you have got available, which approach you will be doing, and what process stages you would carry out, yeah, and how you would be planning the capacity for the existing as well as the upcoming needs of the network. Yeah. Now, the design goals should be, they should be able to deliver the services requested by the users. The main thing, whatsoever the users want, your goal should be to deliver those services, isn't it?
Yes, very much so.
Yeah. So those should be on the finger, tips. Deliver acceptable throughput and the response time. Yeah. So I think you should be okay. You must have heard about those throughput and the response times. Yeah. So the throughput is that how many units of information are processed in a given time, and the response time is the elapsed time between an inquiry on a system and the response to that inquiry. So throughput, for example, let's say that how much data can travel on this network on a cable or a wireless connection. For example, how long it takes, for example, if the data or the request has been made, and actually how long it will take. Yeah, these are the general terms, the two of them, isn't it?
Yes.
Now, so the design goal should be very much clear. Then, how do you want to balance the distribution? Load balancing. Yeah. So the load balancing is that how much load do you want to give on a particular resource. For example, if you have got let's say 60 employees, yeah, and probably a small server may be capable to hold maximum of 60, yeah, users, as a clients of the server. Will you be allowing the maximum number of users to be connected, or maybe you could be looking for 2-3 servers, yeah, that each server may have a reasonable load, not the stretchable load, isn't it?
Yes.
Yeah. So the level of transparency with regards to the manner, the data, you want to be transparent, invisible, in a sense that your the traffic of the data, the protocol, the way you send and receive, how transparent it should be. Make sense? For example, yeah, for example, if you want, let's say within the, a local area network, you may not have a concern of, the security or the breach of the security, or, the any threat of the security that your data could be lost, for example.
Yeah, I understand that now. Yes, yeah.
So level of the transparency it is your choice, but it could be the case that, for example, if you have got a network and your network, your 5 of the computers are connected with a local area network, then possibly within the network you may not have a strong security measures, and from one computer of the same network you can easily access the data of the other computer, possibly. But for example, if it is a sensitive data and everyone has got every user has got a very critical information, yeah, and no one is allowed, yeah, to share with anyone else, then would you be expecting a more transparent, application usage?
No, it would be very, very less transparent.
Yeah. So you would be looking for a very, very strong security measures even within the same network, isn't it?
Yes, yes.
And furthermore, so the transparency is with regards to the protocol and how you would be making it secure. Yeah.
Yeah.
So the transparency is related with the way, whether how invisible those applications, yeah, should be using particular protocol. Obviously, if they are transparent and non-transparent, then it has different characteristics, and then you would be implementing the security. Yeah.
Yes, based on the level of transparency.
Yeah, based on the level of the transparency. Yeah. Then connectivity technology, obviously you will have again the options that which technology you want to use, which technology, as well as which device you want to use. For example, probably you could use the conventional routers and the bridges and the hubs. You could use the Cisco routers, and the hubs and switches, they have a more manageable options, and the security options, segregation options, isn't it?
Yes, yes.
Yeah. So that's the choice basically. Yeah. Then how do you want to design the network? Probably you could go through the traditional analytical design or building block approach. Yeah. So have you heard about the building block approach?
Yeah, I believe it's where you would start with maybe the first part of the network, and then the next part of the network, and you would just keep adding and adding.
Just keep on
adding and adding.
Yeah. So basically, building block approach is that you have got already set of standards, first group of modules or elements ready, then you are trying to integrate them. Yeah. And let's say, for example, you have 10 rooms, and over there are 100 PCs. Yeah. And maybe you come up with an estimate of the number of devices, and then you keep on adding those components, and you probably would be doing fine. That's a one approach. Another approach is that probably you would be planning first, yeah, looking at the requirement, and then see how many how much equipment you need, what type of that equipment you need, and then you go accordingly, isn't it?
Yes, yes.
Yeah. So just there's two terms been advised. Yeah. So approach. So which are you could make do any approach in either way, isn't it?
Yeah, yeah, yeah.
Right. So traditional approach starts with with the requirements, the agreement of the requirements, then you gather the information, then you proceed with. However, in the building block approach, probably you would not be looking at the requirement, you would have a solution, yeah, and then you would be trying to get the advantage of solution by applying the solution to any problem, isn't it?
Yes, that's right.
Right. So stages, so that stage would be that you agree the requirement. So requirement is basically you should be able to agree that what bandwidth you need, what availability you need, application connectivity you need. Yeah. So how you can get this? You engage the end users into the requirement. Yeah. Translate those requirements from business objectives to technical specification. Yeah. So first, for example, when they say I need a computer, yeah, then in your terminology you would be considering a node, a network node, isn't it?
Yeah,
Yeah.
yeah.
So for example, if they say I need one computer, I need one printer, and I need one scanner, yeah, and I want the printer for example on the one corner and the scanner on the another corner, and I want this connected with my computer and my additional computer in the which is the laptop, yeah. So probably you would be looking for the technically you would require four number of ports, yeah, or the
Hmm.
wireless access points which you could get connected, isn't it?
Yes, yes.
Yeah. So business objectives converted into the technical specification. This is how the requirements are received. Yeah. Then phasing the requirements, right level of the detail at each design stage. Yeah. So for example, if you are required to know how many PCs, yeah, and which let's say on the part in computer, for example, in the room, you need two ports for the computers and two ports for the other devices. Then you would not be asking that which driver of the printer they would require, isn't it, in the particular level of the requirement, isn't it?
Yes.
But right level would be maybe that how which type of the printer, which type of the scanner they would require, that the laptop, for example, would they require any cable as well, or the wireless connection should be fine, something like that. Yeah?
Yeah.
Then designing the requirement, you should be able to stick with the design. Yeah. So the requirements would be formally written into the design. Yeah. Like probably, for example, you sketched the four nodes into one room. Yeah.
Hmm. Hmm.
So sorry, this is very basic discussion. Yeah. That you need four computers, four terminals, but these are the part of the discussion of designing a network, isn't it?
Yes, very much so.
Yeah.
Yeah.
For the beginners, it's a good and interesting, the discussion. But if we know that we have to put, these four computers and these blah blah blah. But that's basically the syllabus we have to discuss, and it is interesting, isn't it?
It is, and it's good to remind yourself of
Yeah.
what you need to do.
Yeah. So, and it will help, for example, these points could be included into your assignment write-up, isn't
Yep.
it?
Yes. Yes.
Yeah. You can easily include these, potential slides, that how do you want to include and how do you want to decide and in which way you want to decide the requirements according to the scenario. Yeah.
Yeah.
Then prioritize with a hierarchical system, like what items are important, like a mandatory, highly desirable, and note. Yeah. Note is that you just write down that this could be used, but at a very low priority. Yeah. So these words have conventionally be not words but letters. Yeah. Have been given the priority in this way.
Yeah. Is that similar to like Moscow, like must, could, should, would, that kind of thing?
I'm not sure, but I from somewhere, and so they have advised this kind of hierarchy, like MHDN. So mandatory is the high priority, and highly desirable is the H, D, and N.
Yeah.
Yeah. Then how you would be gathering the information? Yeah. So basically, you need to find the details of the user behavior, application use, and the location. The user itself, and their location, how many users they need, what services they use, and what type of access they need. That's one thing. Site is basically that where the users would be sitting. Let's say you have one site, for example, it's a one office. Maybe you have got 4 sites. Yeah. Then number, then location, then constants on the traffic, and whether any security or cost or political constants would involve. Yeah. Then servers and the services, where would be the server, the how the servers and the level of distribution would be used. Would it be a wide area network, and what would be the traffic in between them. Then protocol support, what protocols you want to uh, network to be supported, routed, or switched one. You need gateways. Legacy support, equipment, protocols, or services. So legacy support is if you are trying to create a network, do you want your equipment, the hardware, the networking hardware, to support any old you know devices, the protocols, the standards, isn't it?
Yes. Yeah.
Yeah. So you understand well what the legacy is. Yeah.
Yeah. It's in case someone still has a dot matrix printer.
Yeah, maybe. Yeah. So then a specific availability, how many hours you need that particular resource. Then 5-year plan. Yeah. So literally, and officially, or a good network should have a 5-year plan. So that changes to the population or business requirement could be fulfilled. Yeah. So within a 5-year, what the company expects. Yeah. Do they expect any change in number of people? Some of the companies might be looking at increasing the staff, but some of the companies might be looking to decrease it, isn't it?
Yes.
So like if there is less automation into the company, then there would be more number of people. Yeah. And if it would be automated, then the automation would be replacing the many human, isn't it?
Yes.
Then budgetary constants, greenfield or existing site. Yeah. So what's the greenfield and the existing site? That's a main thing. That greenfield site is a greenfield. Yeah. So have no legacy constants, but it's difficult to determine the real network loads and stress. needs more detail of application use and underlying protocols, could use simulation to predict performance. Yeah.
Yeah. Yeah.
Existing site could have the limited access. Yeah. Access to live networks could be restricted. Yeah. Bottlenecks, data flow more obvious. Yeah. Can use traffic network analysis tools. So if you need to analyze the requirements, yeah, then you can have two situations. Yeah. One is the greenfield, other one is the existing site. Yeah. So the greenfield will have the advantages and disadvantages. Yeah. And the existing site would have a more advantage and less, a little bit, let's say, less disadvantage because of the accessibility. But you should be able to, measure, yeah, that how the network is, how you want to, want the network to work for you, isn't it?
Yes, that's right.
Yeah. Obviously, in the green field, you will not have the legacy system problems, isn't it?
Yes, that's right, because you'll be starting from new.
Yeah, starting from the new, but you can go wrong, yeah, and if you miscalculated the needs. Do you agree?
Yes.
Yeah.
Yeah, because
Possibly, yeah. Possibly you could, utilize the resources, yeah. I mean, you could have the very much load on the resources, yeah, which could fail the system. Maybe you could have invested extra money or wasted the money and the resources which you never required at all.
yes, that's true.
Yeah. And however, the existing site, yeah, the existing site can really give you this idea, yeah, that what is the bottleneck, yeah, how the network traffic is, how much, the traffic you need, yeah, and with only exception that accessing that particular, those legacy system and the existing system could be some issue, isn't it?
Yes.
Yeah. Then planning. You need to plan. You should have information that how many hosts you should have. Host means, let's say, the computers you need, users you will have, services you will have, the inter-networking needs. Yeah. So it's basically the iterative process of conceptually you design the network, then you analyze it, and then you refine it. Yeah. So this could involve the brainstorming. Yeah. You could get some reviews on it. Yeah. And you could use some modeling tools as well for planning, isn't it? Yeah. So modeling tools maybe, let's say, if you want, the setup of 10, 100 computers, then it would be asking you or advising you that the intelligent tools you would require, for, if it is 100 PCs, then probably 8 to 10, the routers are required, then other Cisco networks or whatsoever, being involved would be required, isn't it?
Yes, yes.
So that planning of users, use, and the design and what you want would lead you to a final draft design. Yeah.
Yeah, yeah.
Then design specification. Once your design is complete, you would be producing the specification, which is a detailed document of the design. It would work as a benchmark for design changes. whatsoever the design you have, and then at some point, if you wanted some changes whatsoever, then you would be referring to that design, isn't it?
Yes.
Yeah. So final design choices and the changes need justification and documenting. Yeah. So whatsoever the design you have, you need to have some reason behind it. Yeah, that why you have chosen this. For example, if you have left one port or two ports of networking, of a device empty, yeah, then you should have some reason, isn't it?
Yes.
Yeah. And if you haven't left any blank, then you should have also still, the reason that, for example, whatsoever the reason that this room is the director's room, for example, yeah, would be allowed to
Yes.
use any extra, yeah, computer or anything else, then you don't need to leave any port, isn't it?
Yes.
Yeah. So furthermore, that documentation is specification used for the implementation purpose. Yeah. Then implementation itself is a project plan to include phased introduction of the new technology. So phase wise, you are installing the technology, then you educate the users, install the whole equipment whatsoever, then test for possible problems, then you do the acceptance testing to prove performance meets requirements. Yeah. And whosoever wants to use it, they should be able to accept it. Then deployment is basically the provide the support whatever you have implemented. Yeah. Then evaluation. Yeah. So network evaluation is basically the need to measure the quality of network, the service quality or quality of service of a network. Yeah. So quality of service in one word, in other words, is a non-functional requirement. You remember?
Yes, that's right. Yeah.
So certain parameters that you want to know, that are the things going right? Yeah. And are you getting what you uh, you know uh, are you getting what you want? Yeah. And how good you got it? Evaluation is that what you expected and what you got it. Yeah. So the areas to be considered for the network evaluation are bandwidth. Yeah. Is the bandwidth evaluated? The expected bandwidth you are using, is it fine or not? So the bandwidth itself is measured in bits per second, the maximum rate that information can be transferred. So for example, you expect the bandwidth of the network, let's say 2 megabits per second. Yeah. Then are you really able to get it? If you can get it and you are getting, then the quality of service is, let's say, 100%. But if you are not getting it, if you are getting less, then quality of service would be 90%, isn't it?
Yes. Yeah.
Yeah. So bandwidth, throughput, latency, jitter, error rate. These are the characteristics which you can evaluate, assess, monitor these parameters, and then you can measure the quality of service. Yeah. Now, so we're talking about like we explained earlier, that yeah, we wanted design our goal, we wanted to achieve a goal of the network plan. We had a choices, we had approaches, we designed the process. When we implemented, then we tried to assess it. Yeah, after implementation of the network, when we try to assess it, it means we want to evaluate whether the network is working fine. So some of these, the characteristics like a bandwidth, throughput, latency, jitter, error rate could be used for the assessment for the evaluation of the network. Yeah.
Yep.
Yeah. Then we talk about the capacity planning and the connectivity option, that how you would be planning the connectivity of your network. You will have the options of LAN, yeah, Ethernet, token ring, and ATM. These are basically the logical topologies that you would be using, because the LAN, the physically whatsoever you will have, but what choice of the logical topology you want in your network, that the way the data should have been traveling. Yeah. And then in the metropolitan area network, maybe you wanted to use, then these protocols would be the choice. Wide area networks, you will have this choice. Wireless, you will have the Ethernet. The IEEE 802.1 is the standard for the wireless cards, and Bluetooth is another option. The GPRS is the another option. GSM is the option, or the dial-up lines. Yeah. So you have it really depends on the what capacity of the network you want. Maybe the other thing is the uh, fiber optic. Yeah, I believe the fiber optic is uses the FDDI. Yeah, and so really depending that you have to plan the capacity of the network as well. Yeah, and then the connectivity options, the determinants, the connectivity would be your choice. These are the protocols again: packet switching, circuit switching, a little bit in depth, but we are just listing it. Then wired or wireless, how much distance you want to cover, what performance you need, what bandwidth you need, and quality of service and the availability you need in your capacity planning. Yeah. And furthermore, here is a graph, yeah, which explains somehow that, for example, wireless LAN can support from 1 MB to 10 Mbps or 11 to 12 Mbps, yeah, megabits per second. And the Ethernet protocol, yeah, the Ethernet itself could support between 10 to 1 gigabits second. Then token ring is somehow this, ATM is this, and then FDDI is ranging from 100 to, let's say, 200 and 300 Mbps. Yeah. So this information after a few years could be extended and could be changed to more support, isn't it?
Yeah.
Yeah. So that's the choice. You have to select it, and then furthermore, the capacity planning would require that is concerned with user response time. That in how much response time, the user response time you are concerned with, isn't it?
Yes.
Yeah. Application behavior and the performance characteristics. Net, that at what performance you want the application behavior, how much network you want to utilize. Yeah, you need to minimize the downtime, maximize service to customers, minimize cost of procurement and maintenance, avoid unscheduled maintenance or redesign, avoid costly upgrades and bad publicity. Yeah. So we are on the last topic of the today's discussion, which is capacity planning. Yeah. So we started with the goals, choices, approaches, then designing and implementation, and until the process design process includes the implementation as well as the evaluation, isn't it? Yeah. And the capacity planning is little bit discussed in more detail. Yeah. And the capacity planning has some of the concerns with these outlining response time, behavior, utilization, less downtime, maximum service to customers, and blah blah blah. Yeah. Then the capacity planning will have stages. How you can plan the capacity? We are going into the capacity planning step by step. Yeah. So how you can plan this? You form a discussion group. Yeah. Quantify user behavior. Yeah. Quantifying user behavior means, let's say 10 users would be quantified, counted. They would be the standard users. Yeah. Quantify application behavior. The 10 applications at the application level would be required. So you can easily know a user can take, let's say, 10 users require 10 GB of data storage. Yeah. And particular the computing power. Yeah. And a particular bandwidth would be used on the network, isn't it?
Yes.
Yeah. So you would have quantified the user as well as application behavior. Baseline. Yeah. The baseline is that what maximum traffic existing network can have. So traffic profiles would be defined in the planning. Yeah. Make traffic projections. What projections are expected. Yeah. And then summarize input data for the design process. You have to summarize that what maximum input could be used into the network. Then assess other data, environmental, location restrictions, deployment constraints, and they also could be involved into the capacity planning.
Yep.
Yeah. So I believe only the words are given, but the meaning to those bullet points should be clear enough to you. If anything is unclear, then you can ask.
Yep, that's no problem.
Is it fine?
Yes, yeah.
Yeah. So the capacity wise, have a discussion. Yeah. Then number of users, number of applications, the baseline of the existing network should be known. Yeah. How much the traffic could be projected. Yeah. The summary of the input, how much the input could be. Yeah. And any other data could be used. So overall, that's the capacity planning that you need to in advance. So in the first step, discussion group. Yeah. Then try to elicit what uses find acceptable and unacceptable, map of services and users and details of the user behavior. Quantify items using user and the service sizing data. Snapshots from data capture and the network management tools. Trace out the key services using protocol analyzers. Guide network implementation. So this one is basically the detail of these stages.
Can I just ask a quick question?
Yeah.
In respect to the assignment,
Yeah.
I am only writing about this theoretically. I'm not expected to actually go and buy routers and run these tools.
Sorry, you are not supposed to?
I says I'm not expected to go out and buy some routers and connect them up and start running these tools.
No.
So
Yeah.
in the assignment, it's a theoretical exercise. So I would say I have done traffic analysis and I need 10 gigabits. That's acceptable.
Yeah, definitely. Yeah. To be honest, at the level of, the level 4 and level 5, yeah, and as much as you know the information, yeah, you should have a knowledge that how the things are done, yeah, that's sufficient, and they are not required, that you specifically, show and prove that you have used any, tools and, in order to analyze the things, isn't it?
Yeah. Okay. Excellent.
Yeah. Like, the level 5 from the OTHM, yeah, the indicative contents and the assignment, the, unit specification is also, somehow flexible, but the level 6 of the OTHM in the IT and computing, at that level, which is the last year of the university, yeah, in order to pass this, the lab demonstration, yeah, is must. The tool demonstration and, uh, the presentation of the assignment, yeah, how you did it, and submission of, the software, and the, the demonstration is mandatory, but not in this, level 5. Yeah.
Okay. Cool.
Yeah. So the capacity planning involves these things, yeah, and furthermore, the each step is explained into detail about the quantifying application behavior, the baseline of the network, yeah, and then, the traffic projections, yeah, and summary of the inputs and these things, yeah. It's okay. You will be able to read in detail
Yeah.
by own.
Yeah. That's fine. I'm comfortable with that, Ajaz.
Yeah.
Yeah.
So that's fine. So I think it's sufficient today for the network design LO2, which was purely based on designing a network. Yeah. So
Yeah.
I tried my best to include, a good stuff into this, session. Yeah. So as much as you understand this, as well as you can add some more, stuff into your assignment, could be good. Yeah. But at least these ideas, I think initially your questions, that what you need to include, yeah, and this could be a top up into your existing material, this slide, isn't it?
Yeah. Yes.
So that's
Excellent.
fine. So we end up the session now, and I see you next week Tuesday. Yeah.
Excellent. Thanks, Ajaz.
All right. Yeah.
Okay.
Most welcome. Thank you, and bye. Yeah.
Bye.